In this video, I will show how to solve the exercise number 6a that is referred to the problem of the naive solution. So, given the naive solution, that is this one, we need to find a better solution for computing the arithmetic mean of some numbers. So let's see the first example that we have. So a set of numbers, that is this one. So we have different type of solution for the arithmetic mean. We have the Pythonist, but with the double fix, and we have our best solution, which is really similar to the Pythonist, as we can see. So let's see what is the output of these four possible solutions of the mean. So let's see the first one. Okay, maybe it's a little bit back. Okay, so as we can see in the first solution, we have 603 for the naive, but it's wrong because the mean of this number is 603.22 periodical. That's why we are using integer, both of the naive and the Pythonist on the first these two solution. So that's the reason behind we have 603. With the Pythonist fixed with the int to float conversion, we have the correct solution. Also, the other one is really similar. So, I mean, is really similar. The the way that both compute the mean. In fact, we have the same mean. But if you are using another set, for example, this one, let's see what we have. So, as we can see here, as we can see here, we have a little difference. Why? Because the Pythonist solution, without the conversion of the double, is basically rounded to 285. The naive solution gives 284, which is not correct, but the first part of the mean is correct. What we are missing is the part after the point, so the 45. In fact, these two solutions are the best one, and they gives the correct mean that we are taking, the correct mean of our set that we are taking in consideration. But let's see here with this one what we get. Well, with this solution we are get 0 because the mean of two numbers that is the same but opposite, so one is positive, one is negative, it gives 0. So it's not a problem for our first solution. But this is only because we are considering a mean of two numbers and the two numbers is the same, but with opposite operator, of course. We have a positive number and a negative number. So the sum of those is 0, divided by the number that we have in the set that is 2 is also 0. But we need also to take in consideration the problem of the overflow. So when we are compute the mean, we need to take in consideration the size of the number that we are using for compute the mean. So if we use this number, we will have an overflow. In fact, why? Because the size of our variables that contain those numbers are less than the size of the numbers that we are taking consideration. So whenever we are compute the arithmetic mean of some numbers, we need always to take in consideration also the size of the numbers, because if we don't take in consideration this, we will have an overflow. So an overflow is basically it occurs when we are doing some operation and the size of the operation don't respect the size that we have in our variables. So the size is too big than the size of our variables. So I hope that with this first set of numbers we clarify the problem that the naive solution is not stable as the Pythonist, but the Pythonist need also to have the we need also to solve the problem of int to float conversion. And of course, we have here basically they are the same code, but the difference between those is that the count here is considered as a double, and the order where we are doing the compute is that basically here we have the count that it starts from 1 and then it upgrade. Here we have the opposite. We start with the count that is 0, and then we are upgrade. So basically this is the same.